Okay, hope my screen is visible.
Yes, sir.
Okay, so as per discussion, today we are going to learn how we can create doubly linked list. As name mentioned, doubly linked list, a linked list that can traverse both direction, left side and right side. Till now, in the singly linked list, we have a node and they have only one pointer. From this node you can jump to the next node. Okay, from this node you can jump to the next node. From this node you can jump to the next node. So these are your header part, and this is your tail. So till now this is known as single linked list because they have only single link between the two node. This node have a single link between the two node. This have a single link between the two node. So that means if from head you can only traverse in the left to right direction. Just new concept known as a doubly linked list. That means ki, is it possible from here I can go back as well as. Till now in the single linked list we have not any option. But the doubly linked list say yes you can. You can maintain two link, one for our next, one for our previous. They maintain the two link, one for next, one for his previous. Similarly, one for his next, one for his previous. The doubly linked list means node contain the two link, one for his next node, what is my next node, and also contain what is my previous node. So such node known as a doubly linked list node. So question is ki, what the tail? Tail have always next point to the tail node. Next should be null. Okay, and the previous should be your previous node. Similarly, in the case of head next should be the next point, and previous would be the null. So head node is the node which previous is the null. Tail is the node which is the next is the null. And all the operations which you did till now for the single link list you can perform with this doubly linked list. These linked lists are used in the really in the all the application. So till now, any doubt about the concept? What is doubly linked list? Linked list that contain the two uh, addresses. One for is previous node address, one for is next node address, and one for the data, whatever the data you want to store. So now our node have a contain three field. One field known as a data, which data are storing. One field known as a next, what is the next address, and one field known as a previous address. So next should be one node. Next should be node that have a same signature like one have a data part, one have a previous, one have a next. Similarly here always. So now whenever we're going to create a doubly linked list, our node always contain a three field, one for your data field, one field for next address, one field for your previous address. Any doubt till now about what is doubly linked list? A
No,
linked
sir.
list that have a two linkage, one known as a next link, one is a previous link. Due to this two link known as a doubly link, they have a double addresses. So let us write the code. Okay, so let us example, I write a class doubly linked list. Okay, a doubly linked list Again, need a node header, the head you can say, and second node tail. Question is key, what is the node? So you can define one like a static class node. Now this node have a first things your whatever the data part you have, and second one node of a nest, and third element as I discussed your previous, right? So in this doubly linked list, your node contain three fields: one data part, one nest address, one previous address, and simply just one constructor so that we can create object. Is it okay? So as usual, all the linked list operation you can perform here. So let us we want to perform add, at least display. Two. I want to show, I want to add. So let us as usually write some add method. Add, it will take your data part, which data you want to add, and here. So as usual, whenever you receive any new data, that means ki first you have to create one node, create a node, and put whatever the data you want to data part, and what would be the next, what would be the previous, we have to don't know till now, just hold it. And whenever we are going to create a linked list, at that time you have to check our header is pointing to something or not. If header is null, that means the linked list is not created, that means it will be my head. Same would be my tail. When in the case of again add method invoke for the new node, you can again create the new node. Whenever you are creating a new node, the second time you are putting whatever the data you have, but you know what is my nest? Nest I don't know, but previous what would be? Previous solely should be the tail. Previous should be my tail. So this is the tail. Next time you can create a new node. Yes, new node. What would be the next? I don't know next. Next should be null. What is the data? Data. What is the previous? Previous should be my tail. This is the tail again. So in this case, whenever you are going to add, you have to consider both scenario. First, let's linked list is not created. That means header is a null. So in this case, your first node would be your created without any previous, without any nest, but you have mentioned this is the head and this is the tail. Next time someone say add one new element. So whenever you next time you can add next time header not equal to null. That means linked list already exists. So our new node, the previous would be the tail. And next would be I don't know. Next would be null. Similarly, for third time, when we are creating third node, what is the previous node? Previous node always is my tail, and what is the next node? I don't know. So next is always null in the case of you creating a new object, but the previous node is always tail. Is it clear what we are going to write in add method?
Yes, sir.
Okay, good. So let's write. So you can create a node. That's a new node. New node. Okay. So here data, we have a data part. There is no problem. Okay. What is the next node? Uh,
Null.
next node null. What is the previous node? Previous node will be always tail.
So, but very first time, if we have just one node,
Hmm.
then previous must be null.
Previous always null. Okay. In the first node, your tail will be null and previous both are the null. Right? So let us again. Whenever no linked list, at that time when we create first node, okay, first node created. This means this should be head after creation, and this should be tell. Is it correct? So how to know linked list is not created till now? Check head is null. If head is null, that means linked list is not created, and this is my first node. Let's assume some linked list already created. Some already created. Let's assume. Then this method invoke. Then this would be your head. This would be your tail. Okay. So head is not equal to null. First, you always check head is equal to not equal to null. That means linked list is already created. Then what you do? You create the new node. Okay. What is the previous? Previous always would be the tail. What is the next? Next would be null. Is it something? Any doubt? Whenever you are writing this add method, you consider both scenario. First, if head is linked list is not created, then what our code do? And let's also assume if some linked list already exists and someone invoke my add method, then what this method do? Right? Any doubt?
No, sir.
So here you check. Here you check. Here you check. If head is null in this is the year. This means ki this is your head is null means your linked list till now not created. Right? So in this scenario, whatever the new node, this would be head, right? So you simply say head equal to new node. Okay, but you know whenever you know new node create, new node is always the last node because we are just you can give exact name add last. Okay, you can simply specify. Always we are adding add means the last element. You can specify and not specify the logic we are building. Here say add would be the last. So always tail would be your new node. Till now it's clear to how you have created first node, first node. The first scenario can be head null. That means there is no any linked list. So just tell this is your head. This is your head, and just out of loop, you also say this is the tail. So let's assume there are some node already created. Assume some already created. Now in this case, this is the tail or this is the head. Someone invoke your this method add. You create a new node. You create new node. So in your new node say, okay, I don't know what would be my next. I don't know, but I don't always know this is a doubly linked list. The next would be the previous would be always tell. So you say keep previous is the our tell, and once this, and then after that you will also make a link here. Tell dot next equal to this. Tell dot next equal to this. You have to mention so that after this node you jump next here and previous here, and in the last you can say this is the tail. Tail always is the last. So here you have to do first you create the new linked list, you create the new node, and then you can say what is my previous. Previous always to the tail, and this is the tail. The tail dot next should be the new node. So here if I write tail dot new node, so that means the linked list already created. So here say whatever the tail we have dot next equal to new node. Any doubt?
No, sir.
Here you are making previous node assuming if this are going to add always last. So here previous node is the tail and head next I don't know, but I here you decide. If there is a no linked list created, then you can say yes, this is my head part, and this is also tail part after the loop, because anytime invoke add method, always this new node would be my last node. So I am just writing this code outside of the this block. And this is the case only when already linked list created. At that time, what you do? Whatever the tail dot next node would be the new node. So let us just write as usual one show method. Just check the my code work or not. Void yes. So have a name note and no any change. Just take a temp. Start from head and just while loop. Temp is still not equal to null. That means your linked list already created. Just print out whatever the temp or the data part and just make one space so that and after that you say temp equal to temp next and let's just print it's my working or not working. Doubly linked list equal to new dot add, just add element and just after the just so it will show one. Good. Let's add one more, two more. That's three. That's one. Okay. Okay. All are new line. Just remove out, out new line. So till now, as expected, it's working. But how you have to ensure our previous link also works properly. Next is working fine. 423 326, right? 423 326. Let's write one more function so that will just print the reverse order from tail to head. Okay. Just you write another function just so reverse. Okay. That means I am starting from tail. Let's tail. Now we have a tail. The tail not equal to null. Just print tail data and just moved tail to previous. Just move to the previous until previous not null. So it should also. That means now this is the our linked list. Our linked list they have a both link. So previously I have started from head to nest, head to nest, head to nest. Null don't print. Similarly, we can start from tail to previous, tail to previous, tail to previous, tail previous null, stop. So that you can ensure that you properly make a link between this previous link as well as. Is it correct? You have to ensure your both link working properly. How to ensure? First using the next, first using the previous. So let's invoke the previous one. It's reverse. It should show. So it should show like 6 3 4. That means our head to net tail you are going properly. From tail to head you reach properly. Till now, any doubt how to create doubly linked list?
No doubt, sir.
So let us now you can write all other operation. Which other operation? Like let's add after or before. Okay, let's we have some linked list available. Both links are here linked. Okay, now I want, let's, this is the 7 element. I want after 7 the new node should be added. Let's here the 3, here 8, here 9. I want to 6 node should be after 6. So you create one 6 node, but after 7 I want it should be stored. So here you write the code. Let's think how you make this relationship maintain from 7 to jump 6. Now new relationship 7 to 6, previously 7 to 8. Now 7 to 6 and again 6 to 8. Again previously 8 to 7 happening. Now you have to 8 to 6 happening and again 6 to 7. So this relationship you have to maintain.
How we will add 6? We can directly write 6 dot previous is equals to 7 and 6 dot next is equals to 8.
Just you think you have to make a relationship.
Or we can, because it double relationships, so we have to write two statements. 7 dot next is equals to 6.
So let us try it. Write it. Okay.
Yes,
This
sir. Now we will
to
write.
think. Okay. All operation like after, you have to write after 8 or before 7. Two operations. You can write first method add after. Just I pass 7. After 7 you can add. Maybe one method add before. Before 7 I want to add something new. Similarly add first, add last. Add last we already done, right? Add last, this is the look like add last, but you have to also write a one function add first, second one is the add before or add after. Okay, are you trying or I can guide you?
We can try, sir.
Let's try it. Okay, else I will guide you how you can write, but
Yes,
always
sir.
after writing any node you have to check both. So normal head to tail. So here mention head to tail and tail to head. That should be clear. Okay. So from head to tail, right? And similarly, so from tail to head. This should always you check. Okay. So any operation you do add first, yeah, add last, yeah, after, before. Always you run these two methods. Ensure that your linkage properly maintained. You able to reverse whole list from head to tail or simply tail to head. If anything miss, that means your link is not properly maintained. Good. So let's try it tomorrow to complete. Okay. Else, still need with I can guide you how you can write the this operation. What do you think? I guide us, or you can do?
Firstly,
Yes.
sir, we can try.
Let's you try so that you can learn. Okay.
Yes, sir.
Okay. Let's try it.